Good day, everyone. Welcome to this webinar. We are excited about a lot of the developments in the database space. If you know Redgate, if you've been a part of our family in any way over the last 20 plus years, you know that we've really held a lot of regard. We like trying to help you understand how to conquer your database problems, and Postgres is one of those. And my story around Postgres and how I got to this place of knowing and loving this database is a journey that's taken one that many of you maybe have started to begin even on your own, knowing another platform like SQL Server and beginning to understand what Postgres is about. And so we want to start with this webinar. Again, my name is Ryan Booz. I am an advocate at Redgate Software. I have been in the data space, the database space, for more than 20 years. A lot of my career was spent in the SQL Server realm, in the Microsoft Data Platform. And a few years ago, I had to change jobs and unknowingly stepped into Postgres. And so it's been a journey of learning this database, learning something I had played with many years ago, and trying to understand how we can be most effective with it. There's my contact information. You're always welcome to reach out and ask for advice or, just what's going on within the Postgres space. So this is the first in a series of webinars we're giving about Postgres and really why it's becoming something to notice and be aware of, particularly if it's not your normal background. And so today's is probably a shorter webinar compared to the others. It's really just giving you background about what Postgres is, where it came from, and what makes it different from what you might be used to, particularly if you are in maybe SQL Server or Oracle. And then we'll go next month, we'll actually start to compare the differences between SQL Server and Postgres. I pulled out 10 key differences. There are certainly more, but as someone that's taken that journey, who has spent many years of SQL Server in that platform, learning how to move into something new that's really close, but not quite exactly the same, I want to pull out some of those key differences for you to help you start to make that transition. At the end of June, we'll then really begin to show you how to do some work within Postgres. Again, looking at it from the perspective of a SQL Server developer, moving on. And then we have a few more webinars through the rest of the summer, and you will certainly see those in social and other ways. Please keep an eye out for them, and we hope that you'll return and join us there. So here's the agenda for the next probably about a half hour or so. Again, like I said, this is probably a shorter of the webinars. We just want to get you up to speed and get you give you the framework for what Postgres really is within this data ecosphere, as it were, ecosystem. So first, we're going to talk about the history of Postgres. And you'll notice that I do say Postgres and PostgreSQL interchangeably, and we'll get to that in just a second. I catch myself fairly often doing that. Then we're going to talk about the different PostgreSQL variants and why it matters, why you need to know what those are. And then we'll just look briefly about why now, what has happened over the last few years, and particularly even the last maybe one or two, and why Postgres has really gained such a foothold in many different places within our technology space. So let's go ahead and get started. So I mentioned that you will notice, and I just do it naturally, and so how we refer to Postgres or PostgreSQL. And so, as we like to do within the technology space, we care about, how we talk about things. And so Postgres is no different. And you'll learn through the history why there are technically two names that it is often referred to as. And so I want to review those with you so that as you begin this transition, you'll know exactly how to refer to the database that you're starting to use. So the first is there are two correct pronunciations for referring to Postgres. One is PostgreSQL. So kind of the SQL just rolls off the end of the word. So it's not PostgreSQL, it's PostgreSQL or Postgres. What is generally not accepted within the community is Postgre. So a lot of people over the years, and again, there's reasons for this, which we will explain, have thought it is Postgre and then SQL tacked on the end, which it is not. So it's not Postgre or PostgreSQL. And it's also not PostgreSQL. Now, that seems finicky, but you will understand in just a minute why that difference has happened over the last few years, really over the lifetime of Postgres, and why there's this kind of contention within the community. Now, the community cares enough about this for good reason. Quite honestly, I agree. You need to know how to refer to what you're doing. There's even some nice little Twitter accounts like this that will actually respond if you happen to post a tweet that says Postgre or PostgreSQL and so forth. It's just kind of funny that we care about what's happening. So let's talk about the history of Postgres. Postgres really goes back to a project in the 1970s, and it was a project called Ingress. It stood for Interactive Graphic Retrieval System, and it was about the graph of data, trying to figure out a way in the relationship between data, and it was really championed by Michael Stonebreaker at Berkeley. Now, there were parts about the IBM System R database that he wanted to emulate. He wanted to take some of those ideas, but he believed there was a better, kind of more mathematical approach to how you could find these relationships between the data. And so in the database called Ingress, the team created kind of a more mathematical approach in a language called Quell, rather than attaching and kind of following what was a developing standard through the late 70s and early 80s around this SQL standard. He really believed that there was an opportunity in how you could find relationships in data and really bought into the Quell language. Now, the really interesting part about Ingress is it was the only database at that time that, because it was an academic research project, you could actually pay a nominal fee and they would ship you the code on, and I would assume tape at that point, but there were a couple research universities and other companies that actually wanted to see that research, and they would pay that fee. And so it was kind of the beginning of what we would consider almost open source. Honestly, it obviously wasn't fully free, but they wanted to share the progress of the research and what they were doing. Now in the 80s, Michael Stonebreaker and his team had gotten some new funding for a new project. And because they'd been at this for 10 plus years, they had learned some new things, and they felt like if they could almost start over again, there was things they would do differently that would make the system more efficient and more useful. And so with some of that funding, I believe the story goes, they kind of redirected some of the funding into this new project. And it became known as Postgres. And it simply is called that because it was after or post the Ingress database. That's why it's become known as Postgres. Now, the unique thing about Postgres is, and this is one of the things that the team was really interested in, was this idea of kind of an object-oriented database, being able to create custom data types and domains for your specific kind of data, not simply, integers and strings, things that you could come up with that would represent the data that you and your needs really required. And so the database was maintained through this concept of relationships. It still really was wrapped around that Quell language and the underpinnings of Quell. So SQL still is not a part of this version of Postgres. And so they tweaked and updated the Quell language so that it became known as PostQuell. It did include a couple new features, and again, still the underpinnings of that mathematical relationship for a graph and how you could find the relationships of data, maintain those relationships of data as you were using the database. Well, through the 80s and into the 90s, research being what it is, the team, Michael, others, had other interests. They wanted to kind of move on to new research. And they had already experimented with this capability of, giving the source code away at that point for a nominal fee. And so they realized there was an opportunity here to take what it essentially was 20 plus years of research and provide it into a community to do something more and better with it. And so that's what happened. The project itself officially ended at the end of June in 1994. And that was version 4.2 of Postgres. And what happened was, because they released it in 1995, a couple members of that team realized that one of the reasons Postgres was not getting the attention of some other databases like Oracle that were starting, and Sybase and others, is they had not been using the SQL language. They were really bought into PostgreSQL. And so that team took Postgres, replaced the Quell language with SQL, and we got not PostgreSQL, we got Postgres 95. So what the team did is said, well, this is 1995. We're releasing this brand new version of Postgres. We want it to be different from what was before. And so we're going to call it Postgres 95. I'm not sure what the thinking was, how they would refer to it in the years going by. Maybe they were taking a cue from Microsoft and Windows. I don't know. The two cool things that were introduced along with the introduction of SQL support was this tool called pSQL. There was a previous tool called Monitor inside of Postgres, the original version of Postgres. And so they took that and they simply continued to augment the capabilities. And we still use pSQL today. And it's a really powerful client for managing, connecting to, and using a lot of the features of Postgres itself. Now, the really interesting thing here with this release of Postgres is it had a much more permissive license. So again, previously you could pay a nominal fee, you could get access to the research, access to the code, and now it became what we would really refer to kind of as this open source mentality. And it was released in September of 1995 with a V1. And so you can already tell there's a little bit of a problem here. We ended with Postgres 4.2. The next year, we released a version called Postgres 95 1.0, and there became a little bit of confusion. And so the team quickly, the following had begun. The team that was showing interest in wanting to contribute to the development of this database was growing quickly. And so in 1996, they essentially formed what we would probably refer to, although it was not at the time, a nonprofit, a group of developers that had a common goal. They had a driving vision for how they were going to develop this database. And so three things happened in 1996. First, the name changed to PostgreSQL. They wanted to separate it from the previous version. They realized the year numbering probably wasn't going to work. And there was something else they realized they had lost in that translation. This group was called the PostgreSQL, and still is today, the PostgreSQL Global Development Group. And we'll explain in just a minute exactly what that group does and how they function today. And in reflection of that version number, they started with the release of PostgreSQL 6.0. And so what they were showing was Postgres, the original database from the 80s and early 90s, was developed up through 4.2. We then removed the PostgreSQL language, added SQL as the primary interactive language with the data, and we wanted to, not confuse people as much, and so we continued the numbering. So essentially what they were saying was we had Postgres 4.2, just Postgres. PostgreSQL 95 would have been Postgres 5, and now we're releasing the newest version with this new development group as Postgres 6. And that's where we've developed from then. So one of the really unique things about PostgreSQL is that it has this very permissive license. There is no other database, at least at this point, that had and continues to have that kind of license nature to it. Now, other databases have taken the Postgres license, and as they develop on top of Postgres, they will take this license as something to start from. What you see on the screen is the total license. There are no other clauses. There's nothing else that you have to abide by. You notice at the very top of this document, it literally says formerly known as Postgres and then as Postgres 95. And now it is known as PostgreSQL. So there's a lot of reasons why you will hear many people, including myself, say Postgres because it is easier. And there's always a little bit of an underpinning group within the community that wishes we would just go back to that because it is easier to say. But it's a nod to the fact that there was a real shift during that transition to base everything we're doing now on the SQL language. So that's what it is. So it's a very simple license, and it really just means you can copy and use this source code to do whatever you would like, as long as this is at the top of your copy of your fork. And so a lot has happened because of that license over the last few years. So let's talk briefly about exactly how the whole thing works then. So how in the world can we have what is becoming a very dominant database that has decades of history and is developed by a distinct but disjointed group of developers that are across the globe? And so it really all goes back to that group in 1996 that manages kind of the workings of just how the energy and the momentum of the community at large. So we have the global development, Postgres Global Development Group, and currently there are 7 members of that group, and they are appointed to the group, and then they, as folks might need to retire or don't have the opportunity to continue to serve, the group themselves will take nominations and they will appoint new members as they do. Now, what's happened is that group over the years, as companies have come and gone, sometimes a lot of members on that group were from one company that really was invested in Postgres. And so they've made a lot of effort over the last few years to make sure there's diversity among different companies, so Postgres does not become a pseudo, a version of a database for a specific vendor, whether that be Microsoft or AWS or Google or anyone else. They really try and keep in, as a community, have really identified they want to have, and I believe it's even in their bylaws, a specific distribution of data. And so what they do is they set the release dates, really kind of coordinate people in release dates. Anytime there is confidential information or confidential stuff that needs to happen as part of the project, they act as a spokesperson for that. And anytime there is some kind of community decision that needs to happen, that is kind of the goal of this guiding body of developers that have been with the project for a long time. Now, there are then the contributors themselves. So there's a much larger group of contributors. At any one time, there could be a couple hundred. Of those couple hundred, there are maybe, give or take, 40 or 50 developers that have been given the authority to review patches and actually bring them into the source code as part of a release. They're active community members and usually folks that people get to know and understand which parts of the Postgres ecosystem and database that they really take charge of and have an interest in. And all of this management is done through the mailing lists that have existed now for almost 30 years. And there's a lot of debate within the community and outside the community of whether or not the mailing list is the most appropriate place to manage the development of Postgres, but that is how it is still currently done. And one of the reasons, there's actually 2 reasons I know that the community has said, why we continue to do it that way. Number one, you have almost 30 years of email discussion and code review discussion that you can look at right now today, so long before distributed code systems were available. And the other is it does still, to some extent, provide a little bit higher bar of commitment to folks that want to contribute to Postgres itself. And so anyone, I'll show you in just a minute, there are ways that you can see right now today exactly what is being worked on within the Postgres ecosystem. And you can see what might be coming in the next 2 or 3 releases right now. And I'll show you that in just a minute. And then finally, you have kind of the core team. So there's all the contributors and everyone I've just talked about, kind of that core team that has some authority over the code base or maybe a specific feature set. A lot of the core team will, own a major portion of the code base, something like the query planner. And so any patches that are made to the query planner, as a community, we understand those core team members will usually be the ones that will be reviewing. They have a long history of understanding about what's going on with that part of the code base, and they really help drive some of those things forward. I did forget to mention, I just noticed at the bottom, you can actually see who these members are and everyone that's contributed at the PostgreSQL.org website, as noted at the bottom of that slide. So how does this really work then? How do you take this group of potentially hundreds of developers who are not associated on the same company, they're not following the same sprint schedule, they don't necessarily have the exact same desires in mind for every part of the database? How do you manage this? And how do you do it over such a long period of time? Well, we have done it in the community now through what we call Commit Fest. This is a cadence that has been running for many years. And essentially, they agreed years ago to say, hey, we're going to commit to 1 major release a year. And then in between those releases, 4 other releases that cycle through bug fixes, enhancements, things that are not a major feature or something that would maybe deprecate another feature. We want to do that at a predictable schedule once a year and otherwise a couple times each year. And so it happens 5 times a year. They run a Commit Fest And if you want to submit a patch, you do it through the mailing list. You work on Postgres, you work on the documentation, whatever it is, you submit your patch. Once it has passed a little bit of muster, it will go ahead and be included into the next Commit Fest schedule as a potential patch. And then what has to happen is those core contributors and other members have to volunteer to review that patch and shepherd that patch through the process. There's a lot of really intelligent, thoughtful conversation around really every patch. It's pretty awesome to see how this works within a global community. And so what happens then is there's a web app that is open to the public. You can go at any time to commitfest.postgresql.org, and you will see exactly what is currently an active patch that is being developed in some way. Now, they all have a different status. It does not mean that all of these patches are about to be included in the next release of Postgres. It means that somebody has submitted the patch or the idea, they believe that it has value, and if enough of the community and the team wants to help shepherd those things through, then they will start to make that progress. Now, I don't have actual numbers. I would say that my experience so far has been that, on average, a small patch usually takes at least 2 commit fest cycles to kind of move through the process. It might take much longer. For instance, with Postgres 15, one of the major features was merge, adding the SQL merge command to Postgres. That has actually been 4+ years in the making. They had attempted at least one, I believe 2 other times. Folks had submitted patches to include merge, and there was enough discussion around the implementation, the potential side effects, potential issues. Eventually, they went back to the drawing board and submitted an updated patch for new consideration. And so sometimes major features can take a significant amount of time, which is a pro and a con depending on what you're looking for. But I believe the pace of contribution and the way that the community is beginning to see their opportunities in doing this has accelerated some of that contribution. And so it's very educational to use the CommitFest website to see what's happening, learn how the process is working, finding patches that might be really important to something you're looking forward to in Postgres, and helping to move that forward. As a really quick example, I posted a blog personally yesterday just about one of the features of Postgres that's been a little bit of a frustration for some people, and just some thoughts on it. As part of that, one of the core team members mentioned that they are actually working on a patch to documentation to improve how that feature is discussed. And so now I have a link to go and see the work that they're doing, and I can be a part of that conversation, moving that patch through to production when Postgres 16 is released. It's really exciting to be able to have that interaction worldwide. And then last, one of the other things that core PostgreSQL global development group really committed to early on was that if we're going to commit to SQL, we're going to commit to SQL. Now, it doesn't mean that everything about the SQL standard is something we have to do. No database in the world adheres to all of the SQL ANSI standards. It's just difficult, right? We all have reasoning. If it's a commercial product, there may be reasons to commit to one thing over another. There may be historical reasons why you choose, or that database chooses, not to implement a specific feature of SQL. But as of Postgres 15, of the mainline 4 tenets of the ANSI standard in SQL 2016, Postgres conforms or supports 170 out of 179. Now, there are many more than just 179 tenets of the core standard. These are like the mainline ways of processing data, commands that need to be validated, things of that nature. So there's been a big focus over the last 25 years of making sure that as we do work within the code base and release new versions, we have a product that is predictable and we understand how it's going to work with other databases. So that's the history. Now, if you've never really looked into Postgres, that might feel very foreign to you. You might not really still understand exactly how this is working out and how we continue to get something that's released multiple times a year with really very little regression at the major level, and yet continues to push new features ahead. So I encourage you to go, if it piques your interest at all, go look at the CommitFest page. Go look at what those mailing lists are for. We'll talk a little bit later about other ways to connect with the community. But it's just a really neat way to start to see how this works. Now, what's happened since 1996 until 2023 is that license and the predictability of how Postgres works in relation to the SQL standard and some of the features that Postgres provides has really opened up a lot of opportunity for other databases to be built on top of Postgres. It's a very permissive license and allows a company or a new group to tweak something that they think or wish they could do with Postgres, but probably isn't going to make it anytime soon into the main core version of Postgres. And honestly, that's the design of Postgres. It's made to be extendable. And so that's one of the ways that we see that happen. So I wanted to put this in here. So again, the base of Postgres is the core database that you can get from PostgreSQL.org through many different systems. It's available. And you will see, the elephant logo this is the official Postgres logo. We call the name of the elephant is Slonik. That is Russian for small elephant, I believe, or maybe just elephant. I can't remember exactly if there's a modifier there or not. And so anytime you see something say Postgres, we do need to decide, or we need to kind of dig a little bit to understand, is this really the Postgres code base that's being used in some new way? Or is it a database that is simply providing a compatibility layer with Postgres, but actually has no Postgres code at all? And that really has started to proliferate the ecosystem around us. And again, I simply point back to the fact that because the team has focused so many years on consistency and that SQL standard, Postgres variant of the SQL language, the features that Postgres supports, has really become the marker for a standards compliant SQL database, right? Whatever that database might be, you'll often see them say, we are PostgreSQL compliant. Whether or not they have any Postgres code whatsoever in them, that is really the reach of what's happened in Postgres. You've probably heard of a number of these variants. Now, I say variants because every database on the screen is not 100% pure Postgres. But every database on the screen starts with the Postgres code base. And so all of these databases, Timescale, EDB, Neon, Azure, Google Alloy, RDS, all of them start with the connection layer and the SQL processing layer of the Postgres code base. So you will be very certain you should have I would say a 99, 98% success rate of moving your data between any one of these databases and your SQL still working. Now, there will be a couple of tweaks, a couple of flavors. Maybe a new thing that has been added to Postgres has not yet been incorporated in one of these databases because they can only update as fast as they follow the Postgres code base. But if you happen to be in Amazon RDS and you want to try AlloyDB, there's a really high chance that most of your PostgreSQL code will simply just work. You can simply back up and restore your database and keep moving on. So it's very portable. However, there are some databases that, again, I said, will often call themselves Postgres compatible. Now, a couple of these might surprise you, but all of these databases, Amazon Redshift aside, have no Postgres code whatsoever inside of them. They are written in other languages. They do not fork the Postgres code base in any way, but they realize that to be successful, using that Postgres compatibility and the SQL standard that Postgres has put out there really makes them much more available and a viable option for tooling and for use cases within other companies. Now, I did say Amazon Redshift is a little bit different, and it's different in this way. The company that Amazon acquired years ago with a tool that became Redshift literally did fork the Postgres code base back in version 8.2, I believe, in the 8. I don't remember exactly which one. So they took the code base, they forked it, and they created a massively parallel processing database, so MPP database, that does column stored data. So you actually can, in some circumstances, connect to Redshift with like an older Postgres driver. The problem is it has been forked for so long, and their intent was never about keeping up with the Postgres code base. They wanted a code base to start with and develop from that point. So Redshift does not support extensions, which we're going to talk about in a second. Redshift does not support many updates to Postgres and the SQL language of the last 10 years. You can't do like a lateral join, for instance, which is really useful when you're writing queries. And so there are a lot of things you can't do in Redshift, but that makes sense because Redshift is a unique database that's been developed kind of on its own now for almost 10 years apart from the Postgres database. So I simply want to make you aware of that. When you see some of these new tools, it doesn't mean they're not valid options for what you might need to do. That's not my point in showing you the screen. It's simply to say that most of these all of these databases I'm showing you will not natively support Postgres, all of the things that you expect it to do out of the box, because they are simply trying to emulate the processing of the SQL commands. They do something different totally under the cover. So just know that. It might mean that you have to use a different language that they have provided, domain specific in some way, to do your work most efficiently. And so finally, then, why now? Hopefully some of these things, as I've been talking, you're starting to understand why this orange line continues to go up when all of the other major lines are going slightly down. Now, hopefully you can start to understand and realize that it really began in that period where, we're trying to understand the NoSQL thing. We're trying to understand I want a feature, but there's a closed code base, whether it's Oracle or SQL Server or something else. Even the transition to MySQL from partially open source and kind of not open source. And so Postgres has always been there. And the features they've added over the last, say, maybe 10 years have made it very easy to extend the database. Excuse me. So the first reason that I believe it is really important now in 2023, and I say this actually looking backwards over the last, maybe 2021, 2020, and so forth, is people are really understanding what this permissive license means as they're looking at costs, they're looking at capabilities. They understand now that it's very portable. That screen that I showed you with all the variants. As I said, in most cases, your data in one Postgres variant to another should be very, very portable with some exceptions. So it allows you to kick the tires very easily. Excuse me. You can download a Docker image. You can install it on your servers. You can power up a VM somewhere in your cloud provider, install Postgres, and anything you do there should be very easily portable for the most part. It's open source, which means transparency. As I've already shown you, you right now can go and look at the development that's happening today, the commits that are being done right now on the next version of Postgres, or the patches that will come on the older versions of Postgres. And so it's very transparent. That actually brings a lot of security. Many companies are looking at who's contributing, what are they contributing, really making sure that there's nothing that is, dare I say, nefarious that would impact business usage. And so that also brings a level of not just transparency, but security. And again, it's very portable. And so there's at least a lot less vendor lock-in at most levels within Postgres. If I realize at some point that a database like TimescaleDB would be beneficial to my new workload, I could take my Postgres database, create a timescale database out of it, and move forward. Same thing with Alloy. If there's a feature of AlloyDB or Amazon RDS or Amazon Aurora that makes sense for maybe a workload I'm now taking on, it's very easy to port, and I don't have to worry about whether or not I'm allowed to do it. The second reason I believe, and probably almost as important as that license, is that Postgres is extendable. This is such a mind-blowing feature that still today, I can't believe this is possible because of my experience with other databases. Back early in the project, they decided they wanted it to be something they recognized that as a core team, we're never going to solve every problem. And so over the life of the development of Postgres, they have put hooks into the code base that allow developers to extend Postgres to do something new without modifying the underlying code base. And so what I've listed on the screen is a very, very small sampling of the different extensions and some of the things they can do. PostGIS is very popular and very useful geospatial database. It's really the preeminent one for doing SQL-based relational data on mapping data. Some really interesting things like HypoPG as a SQL Server user. This is really interesting. I can install an extension. I've not changed anything about Postgres. I've simply added an extension to the database. And now I can create an index that doesn't actually get created, but it allows me to see then if I were to create it, would the query plan use it? And would I benefit from it? Really helpful. And like I said, these are just a really small helping of all the ways that you can use extensions and the extensions that are available. And that's the other part of this. You as a user can even create a simple extension simply using SQL functions. So you yourself can create, maybe you have a helping of many different queries that you use when managing a database. Rather than installing them over and over again in a database, you can package them as an extension and install just that extension into the database. You get versioning, you get the ability of not having to make sure all of those procedures are available. It's a really useful management function on top of expanding the capabilities of the database while maintaining the core functionality. Really powerful, and it's really changed the way that people, I think, have begun to see Postgres. These are just two examples. Actually, I have a third one that I added after this. These are two databases that are services and offerings you yourself could go sign up for. So Citus Data was bought by Microsoft, and Citus, the extension, is actually what powers Microsoft's horizontally global Cosmos DB for Postgres. And so it allows a seamless horizontal scalability for your data. Timescale is a time series database, and it literally works by creating Postgres and installing an extension. And now you get some really neat features around time series data and partitioning and materialized views, index views, if you're from SQL Server, that always maintain themselves and any data that's been updated in the past. So some really cool features there. And like I said, PostGIS is really the preeminent relational mapping way to do mapping within a SQL database. Really powerful. It's been around for a long time. There's some really neat things you can do with that. In fact, it's one of the things that we're looking at, hoping to do more of within the Redgate and even the PASS community to explore. Now, the third reason might be, might not be as surprising. I don't know where your background is, where you come from. But without a doubt, one of the other reasons Postgres has gotten a lot of investment over the last 10 years, at least, is because it's not Oracle. And so there are a number of companies that have taken the Postgres database because they actually share more than maybe other relational databases. And because the license says do whatever you want, they have created flavors of Postgres, so a fork of Postgres that is Oracle compatible. So now you have an Oracle compatible database without the Oracle licensing. That can make a lot of people pretty happy. The couple that I know that are doing it right now, EDB, is one of the major heavily invests within Postgres enterprise database, and they have been supporting and have their own enterprise database called Enterprise DB, and it is Oracle compatible. And so they've helped a lot of clients move their workloads off of Oracle. Cybertech is a European company, really helpful within the Postgres space. They also have a similar compatibility. And then Ivory SQL is pretty new. I just recently met one of the the founders of this project at a conference. And so this is an open source version of something like EDB. Now, it has nothing to do with EDB. It is just an open source database that is aiming to be Oracle compatible. And so that project has been going for just maybe a year or two and worth looking at. So again, it's a way for a common user to use the database to begin to take over their Oracle workloads. And then the last reason before we wrap up is predictability. As I said, Postgres has been going now in its current form since 1996. And almost to a T, with a few gaps, there has been a major release of Postgres every year. Just the last 6 versions from Postgres 10, you can see that it happens very frequently in the late September, early October timeframe. The community is very clear about what is happening, the stage of development, When something goes wrong, they're very clear about why they chose to back something out. For instance, in Postgres 15, they had been working quite a while on adding some new JSON, SQL JSON functionality that had not been completed. And within the last couple of weeks of the beta release cycle before official release, they backed out all of those commits because there was a regression, and there just wasn't time to fix the regression. And so they'll take another crack at it for the next release. This is really powerful. Now, as much as I truly appreciate and love what's happening in other database spaces, when the source is closed and you don't know exactly when a new feature is coming, you don't know the status of the feature or exactly what the feature set will be of that feature, let alone is it going to be released in 1, 2, or 3 years from now, that can be really hard to judge what you're going to move forward with. Now, as I said, some features take many years. There's no guarantee that if in 2019 you would have said, I'm going to choose Postgres because they're about to add merge and I need merge, you would have waited 3 more years to get merge, but you would have seen that conversation along the way. And so there is a lot of value in the predictability. It doesn't mean you upgrade every year, but it gives you the opportunity to take advantage of a lot of new feature sets. And I do believe that's really unique in the database, the major database space right now, just being able to have that consistently and knowing exactly what's going on. And so hopefully you can see that targeted towards late September, early October of this year is the next release, Postgres 16. And so we're going to pause now to see if there are any questions and just to see if anyone has anything that they would need to be clarified. And at the moment, it doesn't look like we have anything new. So I want to add 1 or 2 things in here. I just came back from a Postgres conference on the West Coast of the US. And one of the big features that I saw at play are some of those databases I showed you earlier. Things like Yugabyte, AlloyDB, obviously Amazon has invested heavily. I would encourage you, as you look at those opportunities, if that is the direction you're heading, is to recognize that you have a lot of opportunity for understanding the core tenets and features of Postgres and really what's happening internally for those users and for those platforms specifically. So something like Yugabyte, as I said, it is an up-and-coming database. It is at its core what you connect to, the way that the queries are planned. That is the Postgres code base. Hasn't changed. I don't know if I would say it hasn't changed anything, but it's changed very, very little of that layer of the database. But what they have done is replaced the storage layer of the database to make it much more efficient for very high throughput, horizontally scaled workloads. So one of their core features be something like query any node. So it is a distributed database, replicated, and you can query any node, which is not possible with the core version of Postgres. Now, it also means they've changed the storage layer, so it might not work for everything that you would expect it to. And that does come with some changes about how backups are done and how you might utilize that. The same thing with Alloy. Alloy, again, is a Postgres database. They have really maintained much of that source code, but then they've added some features because they've changed the storage layer, things like columnar compression. So as I said, by default, Postgres, maybe I didn't say this, does not have a columnar index type. But there are many databases and there are some extensions that you can install to get that functionality. And so that's really one of the beauties of Postgres, is seeing how all of these database systems are, these companies are investing in Postgres, hoping to move some of these features along in their own environments. And then the goal and the plan is to upstream that code base into Postgres core so that hopefully in 2 or 3 years, maybe we will actually have a columnar data store index type natively in Postgres rather than having to worry about a feature. And so this is something to explore and think about. Just really so many opportunities. I would absolutely encourage you to think about attending a conference or two. We're going to talk about one in just a minute. There is one other question that's come in, and I love that this is happening because it's working out for many people this way. The question is, we want to migrate our Oracle database to PostgreSQL RDS. Any recommendations? So this is interesting. It's one I didn't add in here, and I probably should have. I'll take a very quick tangent on this. Um, and interesting. Second question has just come in and it says, is there a SQL Server compatible version of Postgres like Oracle? So that's actually what I was going to say. Here's the interesting work that's happened. Aurora, AWS, Amazon, has provided compatibility in Amazon Aurora and I believe RDS for SQL Server through a fork, and what they're hoping will eventually be an extension called Babelfish. So what Babelfish allows you to do is take your existing SQL Server workload. They will help you migrate it into Postgres, but then you can connect to Postgres using all the tools you're used to. SSMS, your code technically is connecting to Postgres, but is doing it through a translation layer called Babelfish. Now, Babelfish is not complete and it's not magic, but I know that Amazon's investing a lot of effort into it because they see an opportunity, obviously. And so there's a lot of work going on there. And so that might be a transition for something like SQL Server. I'll come back to Oracle in a second, where you get some help. You work into something like, into Amazon Aurora or RDS. It is an open source license. I think others will begin to start to see what that extension, that fork is like. And once it's there, you will then begin to see what needs to change, what needs to be changed within your code base for doing that. So that's one path forward. There are some good examples online of unique feature sets, and I will say that's what we're going to cover in the next webinar. At least 10 of the major things that you would have to consider that are different between SQL Server and Postgres as you start to plan a transition like that. Again, that's my background, and so that's a journey I had to walk through and something that I love to talk about and help other people look at. Now, I'd say on the Oracle level, I would say something very similar. Now, I've talked to the team at Ivory SQL. I think that's in its infancy, so that was probably going to be pretty difficult. If you simply want to transition your Oracle workload, it's probably not going to happen in RDS at this time. It doesn't mean it can't, and I know they have a team there that is, I'm fairly certain, is looking at some of the same stuff. But you probably will need help from someone like EDB or maybe Cybertech, and there might be some others I have not come upon recently. Obviously, any of those companies would be happy to talk to you. Most of them actually will end up hosting their database on Amazon or Azure or Google. I think you can choose your platform so that they could help you make that transition. And then you could still access your database through like a VPC. So it's still within your platform of choice. You're just getting help from them. Now, once it's in Postgres, maybe then you've done the major work of updating code that is not pure Postgres compatible, some feature sets of Oracle that just literally don't exist within Postgres. If that's a goal for you, you can then work in that direction. That'd probably be my first suggestion moving ahead. And again, feel free to reach out and I can maybe think through that a little bit more and see if there might be some other ways around that. And then we have one other question here. Is Redgate applying the same tools that they have for SQL Server to Postgres? That is an excellent question, and I'm glad you asked. Thank you so much. That's why I'm at Redgate. I actually was a Redgate user years ago. As I said, I have more than 15 years of experience in the Microsoft space, and I transitioned jobs 5.5 years ago, not realizing that the new company was transitioning to Postgres. And so as I took that journey, I lost some of the tooling like SQL Compare, like SQL Monitor. I lost some of that. And over the last year or so, as I've been doing more within the community of Postgres, I could see and I understood that Redgate was beginning that transition. And just very thankful that they had an opportunity for me to come join the company so that I could help them with that as one of many people that are doing it, and that we could begin to have more of a presence within the Postgres community, because I love how much Redgate has supported the SQL Server community. And that's my hope and my dream, is that we can continue to bring some of that support as well into Postgres. And so the answer is yes, we are. The Flyway is the new vision for multi-platform like SQL Compare migration framework. So it does everything around migrations, doing your schema models, generating migration scripts for you. That is all being done within Flyway. There are multiple versions of Flyway that you can choose from with different feature sets, but it's a great tool. And I share this story really quickly. Because I care so much about schema, and DevOps within database. It was been a long part of my life. I was frustrated some of those feature sets, especially having a schema model, was not available easily in the Postgres space yet. And that is actually one feature set I had not yet experienced in Flyway before I joined Redgate. And I was so thrilled the first couple of days I was here to install the newest versions of Flyway and begin to see that schema model ability and that schema comparison. Space. We have a number of users doing that, and it's been really fun to help the team understand how to monitor Postgres in a really good way. And then last but not least, we are also working through the test data management platform as well, things like database cloning across multiple databases and so forth. So there's a lot that we are excited about, and we look forward to helping you with that.